My name is Leo, and I spent a year building an autonomous kayak. I attend Berwick Academy, and the kayak was my 8th grade innovation pursuit. The idea for the kayak came on a walk with my dad. We were looking at the Isles of Shoals, which is about 6 miles offshore, and he asked me, if you had to send something out there, how would you do it? I considered a balloon, rocket, quadcopter, or fixed-wing airplane, but I decided the most efficient way would be by boat. After giving the project some more serious thought, I decided to attempt it. The goal was for the kayak to travel all the way to Shoals, entirely unassisted. We chose a path from a sea buoy near Portsmouth to another just in front of Appledore Island, a trip of just over 5 miles.
Today is July 16th, it's about 8:15, and we're just beginning to embark on our first launch to the Isles of Shoals with my autonomous kayak project that I've been working on last school year. So we're hopeful for a good journey.
My mentor Jeff Gunn and I started by designing parts. I used Fusion 360 and a 3D printer to create a prototype steering system, which we later made from metal. We tested each subsystem individually to learn how each part worked before trying to install them in the boat.
The kayak has 3 major systems. It's got steering, electronics, and propulsion. It's executing turns nicely, it's going forward quickly, and it's steering itself. So all of those 3 systems are good and in check.
The first time we tested the kayak at sea, a stepper motor controller shorted and the cockpit filled with smoke. We used a spare Arduino and performed that first test with no steering. After more testing, the kayak could navigate the creek behind my house, even with current and wind, but it would leak and slowly fill with water. On our first day of open water testing, we only went about a half mile, but the kayak performed perfectly, although we confused some local fishermen.
The propulsion system of the kayak includes a 12-volt electric trolling motor and, of course, our large marine battery. It's moving forward nicely, and we hope it stays like that. The electronic system in the kayak includes an Arduino Uno, a GPS shield, 2 stepper motor controllers, and 2 consecutive power relays. The Arduino is a microcontroller that runs the processes and tells the other components what to do. It's also responsible for steering the boat and turning on and off the motor, as well as navigating. We have a NEMA 17 stepper motor. That's actuating some bicycle cable, which is pulling on each end of the rudder, and that's steering the whole boat. And that's getting signals from our Arduino microcontroller. So because we don't have a compass in the electronics, the GPS is responsible for telling the kayak which direction it's traveling, and it does that by taking where it was a few seconds ago and where it is now and calculating which way it moved. So it doesn't know which way it's pointing, but it does know which way it's traveling. Alright, so we had a couple fails. We were trying to write our code, and we eventually got it to work, but three of the major ones. Well, first, we failed in simulation. We made a scratch simulation where we had the little boat and the island, and we basically put in the rudiments of the code we wrote in Arduino language, and it wiggled a lot, and then it ended up just doing a circle over and over again. So that totally failed, and we ended up fixing that. We completely rewrote the code and took a different approach to it. And then the second fail was we were trying to navigate in the car. Here's a picture of our little setup. We had 4 LEDs to tell us which way to turn, whether it had a GPS fix, and whether we were within range to stop or not. And so that told us completely, it was completely off for distance. when we were about 100 yards away, it told us we were somewhere in the range of 5,000 meters away. But we fixed that in the parking lot, and it worked on the way home from Home Depot. And the third fail was with one of our code revisions. When we were heading due north, it was dividing by 0, and the entire thing just blew up. It didn't work. And so we fixed that as well by taking a completely new approach again.
On the final day, we deliberately launched the kayak 90 degrees off course. It turned towards the target and made its way directly without anything going wrong. It arrived in a cross current, which you can see in the video because it is pointed off to the right, but it is traveling straight in the mud. I would like to thank my mentor Jeff Gunn for all his help in this project. I could not have completed it without him.